Hello students, welcome to Memoneet. I am Satish Swarup, teacher at Memoneet. I am hereby to start with a new chapter, that is vector. The importance of vector, we know that it is used in every single sort of chapter, and it's quite important for the chapters like magnetism, EMI. We should have a great command in the chapter like vectors. Okay, so without a delay, let's start. One is scalar quantities. The scalar quantities are the one which have only magnitude, but it has no direction. Let's say we have distance. We have traveled 5 meter distance. Okay, so this is telling about only magnitude. Okay, let's say we have 10 mangoes. Okay, this is a scalar quantity. Okay, mass is a scalar quantity. Density, volume, etc. These are the scalar quantities. Vector quantities have magnitude as well as the direction. Okay, it have magnitude as well as direction. Let's say we are traveling to one place to another, and the shortest distance is the displacement. The shortest distance, that it states about we are moving in a particular direction. We are traveling some distance, and we are moving in a particular direction. So this is displacement, and this is a vector quantity. Let's say we have velocity also is a vector quantity. Acceleration, force, etc. We represent a vector. The vector is represented by a line headed with an arrow. The length is proportional to its magnitude. Okay, so let's say we have here, this is a vector. Okay, this is a line headed with the arrow. Let's say we have a vector. It is written as a vector. Okay, and the arrow will stay the magnitude. If we are taking, that is 2 units, it is small than the vector we are taking, that is 5 units. Let's say this is x vector, and x vector is 2 unit in magnitude. Okay, unit in magnitude. Okay, and this is a vector, and it is 5 unit in magnitude. Okay, which have the greater line? So this will be a greater line, because length is proportional to its magnitude. And vector is represented like this. Let we have x vector, we will write x, in the above we will place an arrow. See the different type of vector, that is parallel vectors. Okay, parallel vectors, the vectors which have the same direction, that are called parallel vectors. Let's say this is one vector and this is one vector. Okay, they are parallel to each other, so these are parallel vectors. Equal vectors, let's say vector which are equal in magnitude and same in direction. Let's say we have x vector which is 2 unit in magnitude, and the direction is same as the a vector which is 2 unit in magnitude. Okay, and both the direction have the same, so the vector will represent as this. Okay, these have equal in magnitude and equal in direction. And anti-parallel vectors, what do you mean by anti-parallel? This will be opposite to that, but the magnitude will be, the direction will be opposite. So how we can represent? That is, if a vector is like this and another vector is just opposite of this, and it has the angle of 180 degree. Okay, the this vector will have the angle of 180. In the equal vectors, what is their angle between the both the vectors? It is 0 degree. Angle is equals to 0 degree. Here it is 180 degree. Have opposite or negative vectors. Opposite vectors have equal magnitude but opposite in direction. Okay, let's say we have x vector, that is 2 unit in positive x direction, and we have another a vector which is 2 units in negative x direction. Okay, so the vector will represented as like this. Okay, like this. It have the equal magnitude but opposite in direction. Angle between them is equals to 180 degrees. Sorry, is 180 degree. Okay, and then collinear vectors. Collinear vectors, what it says, that is if 2 or more vectors pass through the same straight line. Okay, they are said to be collinear vectors. We have a man is force. We know that force is a vector quantity. Okay, there is a string here. Okay, a man is pulling the string. Let's say this is the man, and it is pulling the string. Another man comes here, he is also pulling the same string in the same direction. Okay, so this is collinear vector because here it will generate f1, here it will generate f2. Okay, so these f1 and f2 are collinear vectors because they act in the same line in the same direction. Okay, and coplanar vector, if two or more vectors lie in the same plane. So this is two or more vectors lie in the same plane. How it works? Let's say we have a vector a vector in this plane and another b vector is in this plane. This is a vector and this is b vector, and here it is the ball. Okay, let's say it is a ball and we are pulling the ball with force a vector and b vector. Okay, so this is a coplanar vectors as they lie in the same plane. Okay, concurrent vectors, it is the line of the action of all the vector is passing through the same point. Then the vectors are called the concurrent vectors. Okay, let's say we have some point over here and this is the plane, and we have different type of vectors. Let's say here these lie from the same point. So this is known, these all vectors are known as concurrent vector. Null vector or zero vector, the vector whose magnitude is zero and is called a null vector. Its direction is arbitrary and is not specified. Okay, the vector which have zero magnitude will have a null vector. Let's say we have a vector a vector, we add a force add another vector that is negative of a vector. Okay, so we know that when two vectors are added, then the resultant will be vector. Okay, so this is one vector and this is a negative vector of that vector, so it will have zero vector. Okay, in this case zero vector, or we can say that it is a null vector. Okay, then unit vector, a vector whose magnitude is 1 is called the unit vector. The unit vector is represented by a cap or a hat or a caret. It's trying to tell that is the vector, its magnitude is 1. Okay, so how we represent the vector? Let's say we have a vector is equals to magnitude into its direction. Okay, that is n cap. Okay, n cap is the its direction. So n cap is the unit vector here, that is n cap is equals to a vector upon a magnitude. Okay, unit vector is n cap and we are representing that is vector upon its magnitude of the same vector. Okay, so this is how we can represent the unit vector. Standard unit vectors, let's say we have the Cartesian plane like this. Okay, this is the origin here. Okay, and it is x, it is y, and this is z. Okay, in the x we have I cap. Okay, and in the y we have z cap, and in the z we have k cap. These are the unit vectors I, j, k. This k, it is k cap. So these are the unit vectors here. The I cap is directed along the x axis, and j cap is directed along the y axis, and k cap is directed along the z axis. Polar vectors, the vector which have initial point or a point of application are called polar vectors. That is, when we talk about the displacement, it must have the point of, because we are traveling from this point to this point. Okay, it have the initial point or point of application, so these are known as polar vectors. And the axial vector, the vectors which are used in the rotational motion to define rotational effects. So these are the axial vectors. The direction of this vector is along the rotation in the accordance with the right hand screw rule or right hand thumb rule. Okay, so what it is trying to tell, that is, if we have angular velocity. Okay, angular velocity, let's say we have here the line, and ball is traveling, it is the axis, and ball is rotating about its axis. Okay, here the ball, let's say it is going, and here it will have velocity, okay, and the ball is trying to roll, trying to rotate. So the our angular velocity will be in this direction as we apply the right hand thumb rule, which we will discuss in the uh, forward, okay. Of a vector by a scalar. When we multiply a vector with a scalar, let's say we have a vector and we are multiplying it with lambda into a vector, okay. In this the magnitude of the vector will change but the direction will not change. So the b vector will be equals to, that is the resultant vector will be lambda into a vector, okay. So this is how we are will do multiplication of a vector with a scalar. Angle between the two vectors, let's say we have a vector here like this and b vector here like this, okay. When the tail of one vector is connected with tail of another vector, okay, this will be the angle. Let's say it is 60 degree, this will be the angle. Now let's see when it is joined head to head. Let's say we have a vector here and here, that is b vector, okay, b vector, and it is of 120 degree. So this is also the angle of vector will be of both the vectors will be 120 degree, okay. Let's say when we have one tail is connected with other's head, okay, it is the head of the vector and this is the tail of the vector. The arrow is marked as head. Sorry, I have not told you previously. The arrow will marked as head and the tail will be that is the trailing part, or you can say that is the line, okay. So let's say when we are having one vector here, it is a vector and it is connected with the tail of another vector is b vector, and here it has angle of 120 degree between them. So how we can find out the angle between the vectors? Just do nothing, just take one of the vector and join it from either head to head or from tail to tail, okay. Let's say we are displacing the a vector, so how it will be, we will take a vector to move forward, okay. So the a vector will be like this, okay, and the angle between the a and b now will be 60 degree, okay. So this is what we will tell, the angle between the a and b vector is 60 degree, not 120 degree. Let's see another illustration, okay. We have here a vector and here we have, let's say, b vector, it is b vector, okay, and angle between these is 60 degree. So what to do? Please take one of the vectors or move one of the vectors so that we can have either head to head relation or to tail relation. Let's move the a vector forward. So what we will have, the a vector will be like this, will be a vector, and the angle between this will be 60. The 60 is one angle, then another angle, as it is linear, so another angle will be 180 degree minus 60 degree, that is 120 degree. So the angle between these two vectors, that is a and b, is 120 degree. Another, we have here a vector and here b vector, okay, here this b vector, and its angle between them is 135 degree, okay. So what we will do, we will just move the a vector forward, and this is how we have moved the a vector forward, and the angle between this is linear, so 135 180 minus 135, 180 minus of 135 degree is equals to 45 degree, okay. So the angle between the a vector and b vector will be 45 degree. I hope you have understood this concept, because this will be used quite. So now start with the new concept, that is addition of two vectors. So sum of two vectors is the resultant vector of these two vectors. If two vectors are represented by two sides of the triangle in the same order, then their sum or the resultant vector is given by the third side of the triangle that is in opposite order of the first two vectors. Okay. So what it is trying to tell, let's say we have a vector that is a vector here, okay, and another vector which will be in the same order, that is b vector here. Okay. So the resultant vector will be, that is in this direction, when it comes from the tail of the one vector to the head of another vector, and it will also reverse the order of the both the vectors. So this is the resultant vector. Okay, we can also do, that is we have let's say these are the two vectors, let's say we have p and q. Okay, so how we will find out the resultant? Okay, now take one of the vector to the tail of one vector to the head of another vector. Let's say we are displacing p. Okay, we should not deviate any of the magnitude of any vectors. Just we will place from one position to another position. So we have here the q vector. Okay, and the p vector we will displace to the head of the q vector. So the vector here will be represented as p vector here. Okay, so this is p vector, and the resultant will be in this direction, that is, which will be opposite in the order of the p and q. What do you mean by order? It is given, it is going in this direction, that is anticlockwise. But here the resultant, it is opposite of the a and b order. Okay, here the p resultant will have, that is resultant vector is equals to p vector plus q vector. Okay, this is how we can add the two vectors. If we want to find out the magnitude of the resultant, okay, so resultant is equals to, let's say we have vector here a vector, here b vector. Okay, it is a vector, it is b vector, and the resultant is this direction, that is r. Okay, so r vector is equals to a vector plus b vector. So this will be equals to the magnitude of resultant vector is equals to a square, a magnitude square plus b magnitude square plus 2a magnitude into b magnitude cos theta. Okay, cos theta under root. So this is how we can find out the magnitude of the resultant vector, and here the cos theta is the angle between the two vectors. Okay, angle how we have represented, that is angle is the vector of the tail of one vector will be connected to the tail of another vector, or the head of the one vector will be connected to the head of another vector. So to connect it, we have to displace the a vector in this direction. Let's say it is 120 degree given, so the angle between the vector will be 60 degree. It will be 60 degree. Okay. Say our angle between the a vector and the resultant vector is alpha. Okay. So how we can find out the value of alpha here? So tan alpha is equals to, make a perpendicular line here. Perpendicular line. This is that is, let's take it as these two as theta. This is theta. Okay. And this line will be b sin theta. B sin theta, and this will be b this one. Okay. This one will be, this part will be b cos theta. B cos theta. Okay. So tan alpha we can write it as perpendicular upon base. So b sin theta upon a plus b cos theta. This is how we can find the angle between resultant and one of the vector. Parallelogram, law of addition of two vectors. If two vectors are represented by two adjacent sides of the parallelogram which are directed away from their common point, then the sum or the resultant vector is given by the diagonal of the parallelogram passing through the common point. Okay, we have a parallelogram here. It is parallelogram, and the angle will be, arrow will be directed away from the common point. Okay, here parallelogram, it is A, B, C, D, and away from the common point. This is the common point, and it is the arrow will be away from the common point, and the resultant of AB vector and AD vector plus AD vector, the resultant will be AC vector, which will be the diagonal. Okay, this is equals to AC vector, that is diagonal. So likewise, the resultant we can write R is equals to under root of AB magnitude square plus AD magnitude square plus 2AB magnitude into AD magnitude into cos theta. Okay. Cos theta, what is this? Is, let's say, is theta, and cos theta is the angle between the AB and AD. Okay. Of more than two vectors, that is law of polygon. If some vectors are represented by the sides of the polygon in the same order, then the resultant vector is represented by the closing side of the polygon taken in the opposite order. Okay, let's say we have here A vector, here it is B vector, here it is C vector, here it is D vector. This is A vector, this is B vector, C vector, and D vector. The resultant will have the closing side of the polygon, which will be in the opposite order of all those vectors. It is R. So R vector is equals to A vector plus B vector plus C vector plus D vector. Let's say we take an example here. We have P vector, Q vector, R vector, S vector, okay, and let's say it is X vector. So what will be the value of this polygon? So X vector, so for the value of total vector, the sum of all the vectors will be 0, as they are present in the same order. So we can write P vector plus Q vector plus R vector plus S vector plus X vector is equals to 0. Okay, so question here, two vectors having equal in magnitude, that is of 5 units, and have an angle of 60 degree between them, the magnitude of the resultant vector and its angle from one of the vector. Okay. So we have to find out the resultant vector, that is, let's say we have here one vector, that is A vector here, and it is B vector, and the angle between them is 60 degree, and it is of both 5 units. So we can write the resultant is equals to A vector, A magnitude square plus B magnitude square plus 2A magnitude into B magnitude into cos theta. Cos theta is the angle of between the two vectors. So A magnitude is 5 square, that is 25 plus 25 plus 2 into 5 into 5, that is 25. That is A vector, A magnitude is 5 unit and B magnitude is also 5 units. So 2 into 25 cos theta, the value of cos 60 is 1 by 2. Okay, so this will be, if we cut it down, this will be the total value will be equals to under root of 75. We can write it as under root of 25 into 3, or we can write that is 5 root 3. This is equals to 5 under root 3. So this is the resultant between the two vectors. So if you want to find out the angle from one of the vector with the resultant vector, that is tan alpha is equals to we have B sin theta upon A plus B cos theta. Okay. So B sin theta, that is B into sin 5 into sin 60. Sin 60 we have, that is root 3 upon 2 upon 5 plus the magnitude of A is 5 and B is also 5. 5 plus 5 cos theta. Cos 60 is 1 by 2 into 1 by 2. So if we solve this out, we have root 3 upon 10 plus 5, 15 upon 2. So 2 to cancel and 5 here it is 3. So our answer will be 1 upon under root 3. So the alpha will be equals to tan, in which tan 10 degree it is 1 by root 3, it is 30 degree. Okay, so alpha will be 30 degree. So this is the answer for this question. The resolution of vectors. When a vector is split into components which are right angled to each other, the components of the rectangular or orthogonal components of the vector. So what it wants to trying to tell that if we have here a plane and here is axis, it is x-axis and it is y-axis. Let's say we have the vector here that is which is present in orthogonal components, that is a vector. So what if we want to represent in the vector in the x-axis, so what we will do, just take the projection. Okay, this will be, let's say it is theta, it will be a vector cos theta, and what will be the projection of this in the y-axis, it will be a vector sin theta. Write it as a vector is equals to a vector cos theta. It is in which axis? X-axis, means the direction is I cap, plus a vector sin theta j cap. Okay. Pythagoras theorem, we know that a vector will have the magnitude that is ax square plus a y square under root. Okay. Tan theta is equals to a y upon a x. Rectangular components in the 3 dimensions. Let's say we have the 3 dimensional, that is plane, that is here. We have another vector, that is a vector. This is a vector. It makes angle some alpha. So it is alpha with the x-axis, then beta with the y-axis. Alpha with the x-axis, beta with the y-axis, and gamma with the x-axis. Okay. So x, y, and z. So we have the ax component is equals to, that is a cos alpha here, and ay is equals to a cos beta, and az is equals to a cos alpha, beta, and gamma. The vector will be represented as, that is a vector, is a vector is equals to a x I cap plus a y j cap plus a z k cap. So we can write the magnitude of a vector is equals to under root of a x square plus a y square plus a z square. Okay. So here, if we try to write in a simplified way, that is a square, we are squaring both the sides. A square is equals to ax. Ax we can write a square cos square alpha plus a square cos square beta plus a square cos square gamma. Okay. So here we know that cos square alpha plus cos square beta plus cos square gamma will be equals to 1. Okay. A square will be cancelled on both the sides. Let's do one question here. A force is inclined at an angle 60 degree with the horizontal. If the horizontal component of the force is 40 Newton, then calculate the vertical component. Okay. So it is given that the force is inclined at 60 degree with the horizontal. Let's say we have x-axis here and y-axis here. Okay. It is the force is inclined at 60 degree. Okay. It is 60 degree and it is x-axis, it is y-axis, and this the component force or horizontal component force is 40 Newton. So what will be the vertical component we need to find out. So that if we find this is a cos theta, if we take the projection here, that is a x is equals to that is fx. Let's say it is fx. Fx is equals to f cos 60. Okay, that is equals to 40 Newton. So f into cos 60. Cos 60 is 1 upon 2. That is equals to 40 Newton. So the value of force is will be 80 Newton. Okay. So this value of force is equals to 80 Newton. So we need to find out the vertical component. So it is Fy is equals to f sine 60 degree. That is equals to 80 into sine 60 is under root 3 by 2. So this is equals to 40 root 3 Newton. So our answer is 40 root 3. Made by a vector is equals to I cap plus j cap plus k cap vector with x, y and z axis. So in the previous slide I have shown you that here we have the three planes, and let's say it is one vector, that is a vector. Okay, this is alpha, this is beta, and this is gamma. Okay, so how we are writing that? In the x axis the projection will be a vector in the x axis is equals to a vector cos alpha. Okay, so from here I can show you that cos alpha is equals to a x vector upon a vector. Sorry, it is magnitude. Okay, it is not vectors, it is a magnitude. A vector a x is equals to a cos alpha, and it is a x upon a. Okay, the a is the initial vector we have taken. So likewise the cos beta will be a y upon a, and cos gamma will be a z upon a. Okay, so here let's try to find out the value of a magnitude, a vector magnitude, that is 1 square plus 1 square plus 1 square. For why? Because I cap have the coefficient 1, j cap have the coefficient 1, k cap have the coefficient 1. So 1 square plus 1 square plus 1 square is equals to under root 3. Okay, so the ax we have, it as ax I cap plus a y j cap plus a z k cap. So compare this with this. Okay, so we have ax value is 1. So cos alpha is equals to 1 upon under root 3. Cos beta is equals to 1 upon under root 3, and cos gamma is also equals to 1 upon under root 3. So this is the answer of this question. Types of vectors: scalar product of two vectors and the vector product of two vectors. These are the types. Let's first see the scalar. Okay, the scalar product of the two vectors is defined as the product of their magnitude with the cosine angle between them. Okay, so we represent it as a vector. Let's say a is one vector, dot b vector is equals to a magnitude into b magnitude into cos theta. Okay, so this is the scalar product of the vector. When two vectors are multiplied with the scalar product of a vector b vector cos theta. Okay, this is scalar. Okay, so we have this in the scalar, it is commutative. It means a vector dot b vector is equals to b vector dot a vector, and it is also distributive. Let's say we have a vector and b vector and c vector. So a vector dot b vector plus c vector is equals to a vector dot b vector plus a vector dot c vector. Okay, it is distributive. So how to find out the cos theta? Okay, this cos theta, we have a vector here, it is a vector, and it is, let's say, b vector, and we have cos angle of 60 degree. So we can write a vector dot b vector. When we multiply this, we do the scalar product, that is equals to a vector dot b vector, sorry, a magnitude into b magnitude into cos 60. Okay. A magnitude into B magnitude into cos 60, that is equals to 1 by 2. So this is how we can find out the scalar product. Vector dot B vector is equals to A magnitude into B magnitude into cos theta. Now see this. Cos theta maximum value is 1, maximum value is equals to 1, and minimum value is equals to minus 1. I have told you in the basic mathematics. Okay, so the maximum value of maximum value of a vector dot b vector, that is AB. Okay, A magnitude into B magnitude. Minimum value is minus of A. Okay, cos 90 degree. We have the angle between both the vectors is 90 degree. So it will have the 0. Okay, so dot product of the orthogonal vector is 0. Okay, we do the dot product of any I cap. Okay, any unit vectors. Let's say we have I cap dot j cap. These are the orthogonal vectors, so we will have the value that is 0. Then it is equals to I cap dot k cap, or anything you take, that is I cap dot j cap. But here I cap dot I cap will not be equals to 0 because cos 0 is 1. Okay, we have a vector, that is ax I cap plus ay j cap plus az k cap. Okay, and b vector as bx I cap plus by j cap plus bz k cap. And if we do the dot product here, a dot b is equals to ax plus ay plus az, it is I cap, it is j cap, it is k cap, in dot product with bx I cap plus by j cap plus bz k cap. So this will be equals to ax into bx plus ay into by plus az into bz. Okay, this is how we will do the dot product. The topic, that is projection of vectors. Let's say we have here a vector and this is b vector. So what is the projection of b vector on a vector? Okay, so this will be the projection. Okay, the part of the b vector which will directly be present on the a vector. This will be the projection. Okay, this will be the projection, that is if it is having angle theta, that is b cos theta is the projection here. Okay, so we can write that is a vector dot b vector. We have a vector dot b vector, that is equals to a magnitude into b magnitude cos theta. Okay, but here the b magnitude cos theta is the projection, so b cos theta is equals to a vector dot b vector upon a magnitude. Okay, so this is what the b vector projection on a vector. It is important, so try to learn it thoroughly. Okay, topic, that is vector product of two vectors. The vector product or the cross product of the two vector is defined as the vector having the equal magnitude equal to the product of the magnitudes with the sign of the angle between its direction and is perpendicular, containing both the vectors according to the right screw rule or the right hand thumb rule. Okay, so ignore this. Okay, what I am trying to tell, just understand that we have vector a vector and this done cross product with the b vector. So this is equals to a vector magnitude into b vector a magnitude into b magnitude into sin theta. Okay, so this is the vector product. Let's say we have the vector here in, that is a vector, and b vector in the same plane, b vector, and the angle between them is theta. So we have the vector product, as vector product is have magnitude as well as direction, so we need to specify the direction also. So when we are doing a cross with b, so how we can say that we can easily say the magnitude, that is this much. Okay, how we can say the direction? It is also into n cap. So what, how we'll say the direction? Let's say we have in the plane here. Okay, let's say my mobile is the plane here. Okay, it is the plane, and we have a vector here and b vector here. Okay, it is in the plane of the mobile. Okay, and we need to find out the direction of the resultant vector when we are doing the cross product. So what we will do, a cross b, we will put the right hand thumb rule. We will apply here the right hand thumb rule, that is we will place our palm in the a vector, and we will curl our fingers towards the b vector, and the thumb will represent the resultant vector, that is a cross b. Okay, so here let's say we have the a vector is in this direction. Okay, is in this direction, and b vector is in this direction. Okay, so how we need to find out? A vector will be in this direction and b vector will be in this direction. So we are doing put our fingers towards the a vector, then we are call our fingers towards the b, and the thumb will represent the vector product. Okay, we will find the sine theta. Okay, sine theta is equals to a vector cross b vector upon a magnitude into b magnitude. This is the value of theta, that is sine inverse of a vector cross b vector upon a magnitude into b magnitude. The a vector cross product with b vector, that is a magnitude into b magnitude, that into sine theta. A magnitude into b magnitude into sine theta. Okay, here the maximum value of sine theta is 1, and the minimum value is maximum value, and minimum value is -1. So we can write the maximum value of a cross b, that is ab, and minimum value is minus of a. Okay, in which degree? It is in 90 degrees. Sine 90 is 1, and it is in 180 degrees. The sine 180 is minus of. Okay, so this is how we are doing the vector product. I need to tell that if we have here, let's say this is the Cartesian I cap, it is j cap, and there is k cap. Okay, we know that I cross I, this is two vector cross product, and in the cross product we have sine theta. The angle between these two vectors will have 0 degrees. So sine 0 is 0, so it will have 0. That is equals to j cross j, and this will be equals to k cross k. Okay, and then if we have I cross j, we will find that is k cap. Then j cross of k, that is equals to I cap, and then k cross of I, that is equals to j cap. Anything which will be which will have the cross product in opposite manner, then we will have negative in the product side. Let's say we have j cross of I, then what should we have? We have j in this direction and I in this direction. We will curl our fingers in this side. Okay, curl our fingers in this side, and our thumb will representing into the plane of the paper, but the z axis is out of the plane of the paper, so it is minus of k cap. Okay, likewise if we say that I cross k. Okay, I cross k, here it is I and here it is k, and I will put my fingers in the I direction, and I will curl my fingers in the direction of k. Okay, it will be representing, the thumb will be representing downwards, but the y axis is upward and the j cap is upward. Okay, as it is representing downward, so we can write minus of z. Okay, I hope you understand this concept. let's do some question here. Here a vector plus b vector magnitude is equals to a vector minus b vector magnitude. Then find the angle between them. Okay. So we have a vector plus b vector magnitude is equals to a square plus b square plus ab cos theta under root. So then a vector minus b vector, a vector minus of b vector magnitude, that is equals to under root of a square plus b square minus 2ab cos theta. Okay. So here these two components are equal, that is a square, by squaring both the sides. Okay. If we want to square, so this will be as the a vector plus b vector magnitude is equals to a vector minus b vector magnitude. On squaring both the components, so it will not be affect. Okay, so this will be equals to a square plus b square plus ab cos theta is equals to a square plus b square minus 2ab cos theta. Okay. So here a to a cancelled and b to b cancelled. So we have this 2ab cos theta. Sorry, this 2ab cos theta. So this will have 4ab cos theta is equals to 1. It will be 0. 4ab cos theta, it would be 0. So the value of cos theta is equals to 0. In which value the theta will be 0? In the cos, that is cos 90 degree is equals to 0. So theta is equals to 90 degree. Okay. So hence the angle between the both the vectors is 90 degree. Another question, that is a vector is equals to 4 I cap plus n j cap minus 2 k cap, and b vector is equals to 2 I cap plus 3 j cap plus k cap. Then find the value of n so that a is perpendicular to b. Okay. So when a is perpendicular to b, then the which product will be 0? That is cos 90 will be 0. That is dot product will be 0. Then a vector dot b vector is equals to 0. So we can write 4 I cap plus n j cap plus minus 2 k cap dot product with 2 I cap plus 3 j cap plus k cap will be equals to 0. So we have I is we will multiply I with I, that is 4 into 2 8 plus n into 3n minus of will be is equals to 0, that will be equals to n is equals to minus of 6 upon 3, that is equals to minus 2. So the value of n is minus 2. Here another question, that is find a unit vector perpendicular to both the vectors. Okay, this and this. Okay, we have we know that the formula, that is a vector is equals to a magnitude into n cap. We have here the, let's say we have we have to find out the unit vector which is perpendicular to both the vectors. Okay, we know that if a vector, the two vectors lie in the same plane, then the vector product will lie perpendicular to this, because when we do, let's say we have here, let's say we have two vectors, a vector and b vector. Okay, and we will do cross product here. The resultant vector will be perpendicular to both the vectors. Okay, so here the vector is perpendicular to this and vector is perpendicular to this. Okay, so we have a vector cross b vector is equals to a vector cross b vector magnitude into n cap. Okay, so we have n cap value here, a vector cross b vector upon a vector cross b vector magnitude. So let's try to find out the a vector cross b vector. Okay, so we have I, j, k. We will try to find out the determinant here, 2, 3, 1, and it is 1 minus 1. Let's try to solve out it. That is I whole into 3 into 2, 6 minus of minus 1 into 1. Okay, plus minus j whole into 2 into 2, 4 minus 1 plus k whole into minus k whole into minus of 2 minus of 3 minus of 2 minus of 3. Okay, so this will be 7 I cap. It is a minus, sorry, it is minus of minus, that is plus, sorry, minus 3 z cap, and it is minus of 5 k cap. Okay, so this is the value of a cross b. If we try to find out the magnitude here, that is 7 square plus 3 square plus 5 square under root, that is 49 plus 9, 58 plus 25, it is 83 under root of 83. Okay, so our value of n cap will be equals to 7 I cap minus 3 z cap minus 5 k cap under root of 8 upon under root of 83. So this is the value of unit vector that is perpendicular to both these vectors. Okay, now another question, that is diagonals of a parallelogram are vectors a and b. Here these two vectors are given. Calculate the magnitude of area of the parallelogram. Okay, we know that in the parallelogram, we know that the diagonal, that is area, is equals to half into the cross product of the diagonal, that is a vector cross b vector. Okay, so let's try to find out a vector cross b vector, that is equals to I j k 5 minus 4 3 and 3 minus 2 minus 1. Okay, so here that is equals to I cap whole into minus 4 minus 1, that is 4 minus into minus of 2 minus 2 into 3, that is minus of 6. Okay, plus, sorry, the next value will be minus. Okay, minus of j whole into, it is minus 5, 5 into minus 1 minus 5 minus 3 into 3, that is 9, plus k whole into 5 into minus 2, that is minus 10 minus 3 into minus 4, that is minus 12, it will be plus 12. Okay, so our value comes to be, it will be equals to 10 I cap plus 14 j cap plus 2 k cap. Okay, so what will be the magnitude here? It is 10 square plus 14 square plus 2 square under root, equals to under root 300, which will be equals to 10 under root 3. Okay, so area of the parallelogram will be half of the a cross b, that is 10 under root 3, that is equals to 5 under root 3 is the answer. Okay, I hope you all understood this chapter. So try to solve the question related to this chapter, and that's anything you have done.